All right, hello, and welcome back to Real Seekers. I'm your host and teacher, Dale, the Real Seeker, and continuing on with my lessons in logic, my critical thinking and logic philosophy course that I'm teaching. And this time we're going to be moving on to Lecture 5. Excellent. Okay, so just a bit of a quick recap. We learned that there are two types, our main categories of argument that we're learning about. Deductive arguments, an argument intended to provide logically conclusive support for its conclusion. And that is completed. The last two classes were on deductive arguments specifically. In this lecture, we're going to finish off Unit 2 by looking at inductive arguments, which are arguments in which the premises are intended to provide probable or likely support, but not conclusive support for its conclusion. So, looking at inductive arguments, just like deductive arguments, it's composed of various parts. So, an inductive argument can be said to be inductively strong, or it's a good inductive argument, when it fulfills three criteria. So, unlike deductive arguments, which had two criteria, right? It's valid and it's rationally justified. Inductive arguments have three criteria, all of which must be fulfilled in order for the argument to be said to be inductively strong. So, number one, it must be cogent. Number two, it must be rationally justified for one to believe all the premises are true based on the available relevant evidence. So that's exactly the same criterion, the second criterion of a deductively strong argument. But then there's number three, something totally new. The argument must be undefeated or indefeasible, meaning the argument itself, or the more specifically, the conclusion of the argument, is not defeated by the person's total evidence. So that's a new criterion that we're going to be looking at. But before we get into that, let's look at number one, the cogency criterion. What does it mean for an argument to be cogent? Well, cogency, an argument is said to be cogent if and only if it is not valid, but if all the premises are supposed to be true, then the conclusion is likely or probably true. Okay, so inductive arguments, when they're cogent, it means they're not valid. So the argument is not truth preserving. The conclusion is not guaranteed to be true if we assume the premises are true. Conclusion is likely or probably true if we assume the premises are true. So cogency is akin to validity of a deductive argument, right? And note again, cogency is about not about the actual truth or falsity of the premises or the conclusion. Cogency doesn't care at all about that. It's all about that logical structure or the logical relationship between the premises and the conclusion. It's exactly cogency is the inductive equivalent of validity on the deductive side, where it's about the logical structure of the argument or the logical relationship between the premises and the conclusion. I don't give a rat's patoot whether the premises are in fact true or not, or whether the conclusion of the argument is in fact true or not. Irrelevant. All that matters is, well, if we pretend, if we suppose, if we imagine that the premises are true, does that mean that the conclusion is likely to be true or is probably true? Okay, so inductive arguments thus are not truth preserving in the same way deductive arguments are said to be when they're valid. It's even if the premises are true, it's still logically possible that the conclusion is false, but it's just not probable that the conclusion is false. And note, in logic, cogency is sometimes defined differently. So you'll notice in this class, I recommended two textbooks. In one of the textbooks by McDonald, I believe, is one of the authors, they define cogency differently. They define cogency, and they define it in the same way as what we're calling inductively strong, minus criterion 3. Okay, so cogency in that textbook is defined similar to logical soundness for deductive arguments. Okay, the argument is inductively strong, meaning the relationship is good. If the premises are true, then the conclusion is probably true, and the premises are true. Okay, so that's what one of the textbooks calls cogent. We're defining that different. We're following Richard Feldman's definition, and again, I think it better mirrors the way we're learning the about deductive arguments, and this is the proper, a better way of going about this to define it. So for us, it's flipped upside down, right? Richard Feldman says cogency is akin to validity, and then we have deductive strength and we have inductive strength, which factors in the multiple criteria there. Just understand that if you look it up on the internet, cogency, you might get varying definitions. We are following Richard Feldman's definition in this course, which basically is making it akin to validity in deductive arguments, right? This cogency just applies to inductive arguments, and it's only caring about that logical relationship. The truth or falsity of the premises in reality or the conclusion, irrelevant. We like deductive arguments, we can conduct what's called the cogency test. This is again a mental test or thought experiment in your head, similar to the validity test, where you ask, okay, let's suppose, imagine, presuppose, assume, pretend, whatever word you want to say, that the premises of the argument are true. Does this entail that the conclusion is likely or probably true as well? If the answer is yes, then the argument is cogent. If the answer is no, then the argument is non cogent. And just a quick thing here. So if the answer is no, it could be that the argument is valid, right? Because obviously, yeah, if it's not just likely, it's so when you're doing cogency, you first have to ask, okay, well, is it valid or not? Does if the premises are true, does that guarantee the conclusion is true? And if you go no, okay, great, so it's invalid. But is it a cogent argument? Is the next step. So there's kind of a two-step process with the cogency test, whereby you have to conduct the validity test first, determine that it's invalid, and then you go, okay, it's invalid. Is it cogent or non-cogent? And that's where you do this cogency test. Again, if the answer is yes, that the conclusion is probably true, given we assume the premises are true, the argument's cogent. If the answer is no to that thought experiment, then the argument is non-cogent. Okay? So going on with cogency, let's give an example of an inductively cogent argument here. So premise 1, quitting smoking tends to improve one's health. Premise 2, Tyler has quit smoking. Premise 3, therefore, probably Tyler's health will improve. Now, notice that the argument is not truth preserving, right? It's not valid because even if we assume the two premises up here are true, for the sake of argument, let's pretend, let's imagine, let's conceive of, let's presuppose, whatever you want to say, that doesn't guarantee, it's not therefore Tyler's health will improve. No, maybe his health will decline because he gets cancer anyways, or he's been exposed to a nuclear accident, a nuclear bomb, or maybe he gets hit by a bus, so his health declines. It is logically possible Tyler's health will decline, even if he has quit smoking, and quitting smoking tends to improve one's health. Well, great. There are ways to have bad health that don't involve smoking. So it is logically possible the conclusion is false. So here we are saying it's cogent. Therefore, probably Tyler's health will improve. Given the premises we have, yeah, probably it will improve. Now here's an example of a non-cogent argument. Premise 1, a few politicians are corrupt. Premise 2, Dale is a politician. Conclusion, therefore, probably Dale is corrupt. And that's wrong, because even if we assume the premises are true, which in fact they're not, let's face it, basically many politicians are corrupt, or I think we would have to say that all Democrat politicians are corrupt. Scumbags, man. But yeah, so a few politicians. Okay, well, that's not the majority. That doesn't make it like the conclusion likely that I'm corrupt. Maybe I'm one of the many politicians who aren't corrupt. If only a few politicians are corrupt, that means there are many politicians, or most politicians, are not corrupt. Maybe Dale is one of those politicians. Okay, so in that case, it's Not a cogent argument, because even if the premises are true, the conclusion is not likely or probably true. Now, understand that because the truth value of the premises is totally irrelevant to the question of cogency, the following combinations can be said to be cogent arguments. So, one where you have all true premises and a true conclusion, one where you have all false premises and a false conclusion, such as all chairs have 10 heads, Justin is a chair, therefore probably Justin has 10 heads. That's a cogent argument, even though all the premises and the conclusion are false in reality. Likewise, you can have all true premises and a false conclusion and still be a cogent argument. And finally, you can have any combination, right? Some premises are true, others false, and you have a true conclusion, or another mixture. Some premises are true, others false, and you have a false conclusion. All of these combinations, you can still have a cogent argument. So the truth or falsity of the premises and conclusion in reality is totally irrelevant to the question of cogency or non-cogency for an argument. Okay, so let's look at some common inductively cogent argument patterns now. And with inductive arguments, they don't have names like the deductive argument patterns have, right? Modus ponens or universal modus ponens, hypothetical syllogism, stuff like that. Okay, so first, inductively cogent argument pattern. Most A's are B's. Premise one. Premise two, X is an A. Conclusion, therefore, probably X is a B. This is cogent, right? And we can give it an example. Most professors have PhDs. Dr. William Lane Craig is a professor, right? Conclusion, therefore, probably Bill Craig has a PhD. This is a cogent argument. And in fact, the premises and conclusion happen to be true. Okay, great. Actually, the conclusion is false because William Lane Craig doesn't just have one PhD, he's got two PhDs. That brilliant genius of a Christian apologist. Jeez. Uh, Outstripping the atheists everywhere we go. Anyways, but this isn't Christian apologetics. Okay, so another argument, cogent inductive argument pattern, is premise one, X is an A. Premise two, X is a B. Premise three, most ABs are C. Therefore, probably X is a C. So let's give a good real world example of this, right? So you have example, premise one, David Russell is really dumb. X is an A. Premise two, X is a B. Okay. David Russell is a heretic. Premise three, most ABs are Cs. Okay. Most really dumb heretics are damned to hell. Conclusion, therefore, probably David Russell is damned to hell. That's a perfectly cogent argument, and it logically follows. The conclusion is probably true. That's correct. And here's a good way of illustrating some non-cogent argument patterns, right? So you have premise one, most A's are B's. Premise two, X is not an A. It's kind of similar to denying the antecedent, right? Therefore, probably X is not a B. And you can see that this doesn't follow, right? Most A's are B's. So the small circle is the A. The big circle represents the B's. And you can see most of the small circle, most of the A circle is within the big B circle, but there are some where they don't overlap with the big B circle. Okay, so when we find out most A's are B's, great, that's the circles, that's premise one. Premise two, X is not an A. Okay, great, so X is out here, right? And they're going X, conclusion, X is not a B. So they're saying the X should be out here, outside of both circles. But that's non-cogent because it's possible and probable. And we just have no way of telling whether it's probable or not that X is not a B. No, it's equally probable. Maybe he's outside the B circle, maybe he's inside, as I've depicted here. Those are equal probabilities. Okay, next up, most A's are B's, premise one. So again, we got the same circles overlapping most. X is not an A. Oh, I'm sorry, down at the bottom. Most A's are B's. X is a B, therefore probably X is an A. Well, no, this is non-cogent because we just have no way of telling. Maybe the X is here. Maybe, Zola in this example. Most professors have PhDs. Okay, Zola has a PhD. Therefore, Zola is a professor. No, it's we just have no way of telling. It's equally probable that Zola is a professor, and equally probable that they're not a professor with a PhD. There are plenty of non-professors who have PhDs in this world. Great. So just kind of summarizing, that's it for cogency. Now, this is what makes up the difference between a well-formed versus an ill-formed argument, right? So well-formed argument, as you can see on the table, uh, deductively valid arguments are well-formed, where all the premises are true, the conclusion is guaranteed to be true. And recognize validity does not come in degrees. An argument is either valid or it's invalid. Another type of well-formed argument are well-formed inductive arguments that are cogent. Cogent inductive arguments are well-formed, where if all the premises are true, the conclusion is likely or probably true. Now note, cogency is different. Cogency does come in degrees. One inductive argument can be more cogent than another, depending on the strength of the premises. So for example, if one of the instead of most A's or B's, I say 60% of A's are B versus 90% of A's are B. Well, obviously, 90% is higher than 60%, and that means we would have a conclusion. Well, there's a 90% probability that, or likelihood, that the conclusion is true versus a 60% likelihood that the conclusion is true. So one inductive argument is more cogent than another. Now, if an argument is neither valid nor cogent, then it's garbage and rubbish. No, then it's what we call in philosophy an ill-formed argument. It's an argument that the logical structure is ill-formed and not properly formed to create a correct argument whereby we can infer the truth of the conclusion, at the very least on the balance of probabilities, or better, based on the truth of the premises, or presumed truth of the premises. Okay, so let's move on. Inductive arguments. Let's look at the next criteria number 2, justification of the rationally justified in believing all the premises are true based on the available relevant evidence. Now, this is basically the same considerations as we gave in the deductive argument criterion number 2. So everything I mentioned there in lecture 4 is exactly the same here, right? You have the principles of rational and proportional belief, and you have to match the strength of your justification to and belief, or degree of belief or credence, based on the degree of evidence or warrant or justification that you have for believing that the premise is true. Okay, so I'm not going to repeat that. That you can go back to lecture 4, and again, rational justification criterion for inductive arguments has the exact same considerations as it does for the rational justification of the premises for a deductive argument. But let's look at that new third criterion, the indefeasibility criterion. It has to be undefeated, not defeated. This is unique to inductive arguments. It's not a criterion for deductive arguments. Why on God's green earth would that be? Well, remember, the inductive argument's conclusion is not necessarily guaranteed by the truth of the premises. So it's possible the premises are true and yet the conclusion is still false. And that means that an argument's conclusion can be defeated. So it's, again, when we're talking about defeat, it's the conclusion, not the premises or the argument as a whole, that's defeated. It's the conclusion that is defeated if and only if, quote, it is justified for a person to believe some other claim based on having good reasons or evidence to think that the conclusion is either false or that one should suspend judgment about the conclusion's truth. So again, the premises are not defeated, nor is the argument. It's the conclusion that is said to be defeated in this criterion. And in order for it to be an inductively strong argument, the conclusion can't be defeated. It has to be undefeated. Okay, so what does it mean? A little bit more about this defeat, right? So let's think about it this way. A person may have evidence uh, in terms of their total evidence, as Richard Feldman puts it, which includes evidence outside the available relevant evidence related to the premise, truth or falsity of the premises of an inductive argument. Okay, and this can totally change the game. So you have outside evidence, evidence that's irrelevant as to whether your premises are true or false, but it is still relevant as to whether your conclusion is true or false. So here's an example: a court TV show. Obviously, they play tricks on the audience, right? So they'll present selectively only certain parts of the evidence up until right until the end of the episode, where you're like, well, based on the available relevant evidence, I'm going to make an argument that Jim Bob is guilty because, yep, a witness saw Jim Bob running out the door. Second premise two, Jim Bob Pete was the only person in the vicinity of the crime at the time. Therefore, Jim Bob did it, right? And the evidence for those two premises may be rationally justified in believing that, and therefore believing the conclusion. Until, oops, burst open the court doors, in comes a new evidence, some new evidence pertaining to the falsity of the conclusion that Jim Bob is not guilty. He's innocent. Okay? And it's last minute evidence. It's outside of the evidence relevant to the premises, but it's saying, actually, we can prove Jim Bob was not the only person in the vicinity. Or, sorry, we can prove that um, uh, it's not related to the premises. So we can prove that there was a drone flying overhead and shot and killed the victim. It was not, therefore, we know it's not Jim Bob Jones who shot and killed this person, and pretend there is evidence proving that it was this drone that actually killed the person. So in this case, your total evidence, this new evidence, outside evidence that comes in at the last minute, mean it defeats your belief in the conclusion, the truth of the conclusion, despite the fact that it leaves the rational justification and cogency of the premises totally alone. Here's another example that might help, right? Premise one, most plumbers are older than 40 years old. Premise two, Jim Bob Jones is a plumber. Conclusion, therefore, probably Jim Bob Jones is older than 40. And let's say, okay, great, we do a statistical analysis, we get all the available relevant evidence, and it's reasonably justified to believe these two premises. We have absolute proof Jim Bob Jones is a plumber. We've seen his ID card. We've seen him in the act doing his job. We called his employer and he said, "Yep, Jim Bob Jones is one of my plumbers." And we also gain evidence from statistics and wherever else that most plumbers are in fact older than 40. Great. In that case, we can rationally infer that probably Jim Bob Jones is older than 40 based on the evidence relevant to those two, the truth or falsity of those two premises. Now, what happens if I get premise independent evidence? So let's say that Jim Bob Jones presents you with his ID, that his driver's license, and that has his date of birth on it. We realize he's only 39. He's not older than 40 years old. Okay, great. Now you have external premise independent or premise outside evidence, outside premise evidence, proving the conclusion is false. It defeats your belief in the conclusion's truth, even though you're still rationally justified in believing both premises one and two. All right. So that's how defeat works as a criterion for inductively strong arguments. So again, here's the recap. Inductive arguments are said to be inductively strong or good when it fulfills all three of the following criteria. The argument is cogent. Two, it's rationally justified for one to believe all the premises are true based on the available relevant evidence. And three, the conclusion is undefeated or indefeasible. In other words, the argument has not been defeated by the person's total outside evidence. So that means inductively weak arguments may obtain if one or more of those three criteria above fail to obtain. So, for example, there are four ways for an inductive argument to be said to be weak. Number one, if it's cogent but rationally justified and undefeated. Number two, if it's non-cogent, um, or if it's not rationally justified, or if the argument's conclusion is defeated by some other piece of evidence, or any combination of the above, right? So long as you have one or more of the criteria, that three criteria here that fail, then it's an inductively weak argument. And here's a helpful visual. Again, it's not perfect because you'll see, right? But it compares and contrasts deductive versus inductive arguments. So with deductive, you have it's either valid or invalid. If it's invalid, it's automatically deductively weak. If it's valid, then you ask the next question: are the premises justified or unjustified, or not? If it's justified, then it's a deductively strong argument. If it's unjustified, then it's deductively weak. Now, obviously, in this chart, there's another possibility for an argument to be deductively weak, and that's if the argument is both invalid and unjustified, right? Now, with inductive arguments, you have to ask, is the argument cogent or non-cogent? If it's non-cogent, it's automatically inductively weak. Now, if it's cogent, then you have to ask, and are the premises justified or unjustified? If it's cogent, but the premises are unjustified, it's automatically inductively weak. If it's non-cogent and the premises are unjustified, it's inductively weak. But if you get a cogent argument and it's justified, then you ask the third round of questions. But is the conclusion defeated or undefeated or indefeasible? If it's defeated, then it's inductively weak. If it's undefeated, only that. A cogent, justified, undefeated argument is inductively strong. And remember, this doesn't depict the combinations, right? So it could be non-cogent and unjustified, and yet undefeated, and it's still inductively weak. It could be non-cogent, justified, and defeated, and inductively weak, so on and so forth. Any combination. Okay? That's it. So that covers it for Unit 2 on the deductive and inductive arguments, guys. We've completed the first two units, and next time I might be taking a break until July, just so I can work on some other stuff that I need to get done. But we'll start the first lecture of Unit 3, and this is where we're going to start getting a lot more practical in the unit on argument reconstruction. How do we take what we've learned in the past 5 lectures in terms of arguments and the different classifications or categories of arguments, and how do we take that and apply it in our knowledge in life to arguments that we hear out in the street and be able to reconstruct someone else's argument or someone's argument to represent them properly? That's what we'll be learning about next time. So thank you very much and have a great day.